architecture which defies movement in its bricks and mortar, in its stability, it's precisely because of the defying that I'm interested in moving it, for no other reason, to see what is it that is so unmovable. Why do we assume that it can't be moved? I'm only interested in architecture insofar as it's a vehicle to investigate phenomena that seem to be fixed and static.
Dynamic architecture. One of the newest modern architecture design concepts. It is a concept through which buildings are designed to allow part of the structure to move without reducing the overall structural integrity. It is a concept that allows building to keep moving, forever changing the shape to fit environment, urban context, to fit function, technology, and imagination. Building could follow the sun, move to the wind, interact with people. Also, building has the ability to produce energy on its own. From now on, I believe modern architecture will not be a rigid shapes. Construction will have a new approaches. Design will have more flexibility. City will grow and change faster. The form of the building will change constantly, bringing a new views and experience. Building will react and interact, bringing new boundaries. We assume we started the era where building become alive.
According to the rubric in achieving this project, we had to follow certain subsequent steps. The first step of the project is choosing a location depends on its weather in a temperate climatic zone. Study the area that inspired us with the design concept, and it will be explained later in this video. Design a dynamic public pavilion. Take into consideration sustainable materials for construction. Simulate our design by using IAS as the main simulation tool. Assess thermal, wind, and light performance to the gap under the pavilion for 3 scenarios that correspond to 3 seasonal scenarios in 3 different hourly changes per day. Compare our result to the chosen country's sustainability assessment method, which is lead in our case. At last, compare the new result against the base case, that is the gazebo in the static mode.
Sao Paulo in southeast Brazil is the most populous city in the southern hemisphere and one of the biggest on the planet. This once modest missionary outpost has grown out to become the country's economical and cultural powerhouse. An eye-catching building of a completely different kind is the Ibirapuera Auditorium, designed by Brazil's prolific architect Oscar Niemeyer. It's part of Ibirapuera Park in the south of the city. It's a city of culture, creativity, hospitality, and art. Sao Paulo today rides a wave of positive energy into the future and is truly a destination that is much greater than the sum of its parts.
The project proposed to take place in Sao Paulo, which is a municipality in the southeast region of Brazil, precisely in Ibirapuera Park. That's a major urban park in Sao Paulo. It has a large area for leisure, jogging, and walking, as well as a vivid cultural scene with museums and music hall. Its importance to Sao Paulo is often comparable with the Central Park in New York City and Golden Gate Park to San Francisco. The orientation of our project can be illustrated as shown. After conducting solar analysis of summer and winter sun, it illustrates the solar pattern and the way pavilion casts and creates shadow. The open part of the pavilion is located towards south, and the closed part faces north, protecting its inside from frequent wind that usually blow from northwest towards southeast. As can be seen from the graph, all months of the year are falling in comfort zone. Besides that, Sao Paulo's temperature goes below 10 degrees Celsius in June, and it could also go 30 degrees above in October. It can be noticed from diurnal average graph that the highest temperature is in December, while the lowest one is in June. When it comes to illumination, months that receive the highest amount of illumination are November and December, whereas the lowest amount of illumination is in June. As shown from this figure, it demonstrates the sky cover range conditions. The sky is clear all the year, and this will lead to intense direct solar radiation. The wind wheel illustrates the dominant wind direction and the temperature ranges. It It clearly noted that the model will witness high-speed northern and southeastern wind, temperature ranges between 0 to 38 degrees Celsius.
Ilha de Queimada Grande, also known as Snake Island. It is an island on the coast of Sao Paulo. The term Queimada in Portuguese means to burn. It was said when locals attempted to clear land for banana plantation on the island. They had to clear it first by burning it, which kills the snake normal predators. The snake became trapped on the island when the sea level covered up the island connection with the mainland. The snake increased rapidly in population and made the island one of the most dangerous places on earth. The island was thought to have a population of about 430,000 snakes, which is about 5 snakes per 1 square meter. But recent estimates are much lower. This might have happened either because there was a limited amount of resources or either because of climate change. The island also known as the only home of some endangered snake species, like golden lancet and pit viper. Our pavilion function is to raise the awareness of people about endangered species. Manipulating environment is driving animal and plant to extinctions due to the destruction of their natural habitats, hunting, and climate change. Snakes are a fascinating creature. How they move that quickly. Snakes move in a wavy motion. The movement also is known as lateral undulation. Lateral undulation, which is waves of lateral bending along the body of the snake from head to tail. Whenever a bend contacts a surface, it creates a lateral force against it and deform locally around it. Whenever a snake pushes against multiple objects simultaneously, the lateral force vectors cancel each other, which push the snake forward. Different wave gives a snake a control over the direction. As the snake progresses forward, snake muscles move in a sequence movement along its body. The muscles are active in each bend, from a convex to straight to concave shape. This muscle movement allows them to bend in 3 directions, X, Y, and Z. Our project design concept is inspired by this motion. The project concept was developed on several stages. Firstly, based on the snake skeleton, but we failed to achieve the required motion. Then we tried to control the motion by an external structure, which deviated the required design concept. Until we reached the final design. The project dimension is about 42.7 by 50.7 meter with average area of 535 meter, creating about 92 linear meter path and width that varies between 5 to 8.5 meter. The clear height varies from 4 meter to 6.5 meter. The floor level varies between -1 to -2 meter from the park level. The project consists of 32 aluminum tubes called the ribs, running on a track with different height, connecting together with a PVC semi-transparent sheet. The motion in X direction is achieved through the project layout and the variation in the pavilion width. The motion in Y direction is achieved by the rotation of the ribs in the Y axis. The motion in Z direction is achieved due to the different height of the track and the finished floor levels.
According to our pavilion's design, our base case is divided into 3 rooms. The first one is facing east, while the second facing north, and the last is facing west. To assess the thermal performance, we had to conduct suncast analysis on those 3 rooms. For the base case, the total solar gain was measured to be 6.160 for east room, 4.403 for North Room, 6.353 for West Room. And here are some shots that showing sun exposure contours. This chart shows the daylit hours in June and September from 7 a.m. to 5 p.m. and in December from 6 a.m. to 6 p.m. After examining daylit hours, Scenario 1 shows these contours and solar gain was measured to be 2.781 for East Room, 2.66 for North Room, 2.175 for West Room. The illustrations that follow shows the shadows examined in June, September, and December at 8 a.m., 12 p.m., and 4 p.m. For Scenario 2, the total solar gain was measured to be 3.287 for East Room, 2.527 for North Room, and 3.312 for West Room. In Scenario 3, the North Room sees almost no sun and it appears all in blue contours, and the solar gain was measured to be 2.781 for East Room, 1.670 for North Room, and 2.175 for West Room. For the lighting analysis and contours, we are going to compare our three scenarios against the base case in three different dates. 21st of June presents winter. For spring season, it's examined on 23rd of September, while summer in December 21st. For ventilation analysis, we have examined external velocity, pressure contours, and internal wind circulation.
Random photocell sensors are put randomly around the pavilion where all sensors are connected together with a computer program. They are used to calculate the sun direction and the light intensity. The average reading is taken for the light. Lower and higher reading are eliminated from the calculation. This calculation will control the pavilion dynamic movement to match day-to-day light intensity and sun direction. The RIPS is a lightweight aluminum square tubes, 3mm thickness. The RIPS is moving on a stainless self-adjusting steel railing that can move on a linear direction or a curved direction. There are 32 main RIPS, each are carrying flexible photovoltaic cells, 300mm width and 4.5 meter height. The electricity generated from the photovoltaic cell is used to charge the main battery through wire running under the railing. Each two RIPS is connected with 5 fabric strips. Each strip is connected to a motorized roller installed inside the RIP. The roller motors are charged directly by the photovoltaic cells. The fabric is a PVC coated polyester mesh with weight of 130 grams to 350 grams per square meter and thickness between 1.2 mm to 2.5 mm. They are flexible and lightweighted, weather resistant, waterproofing, and provide 38% transparency. LEED, Leadership in Energy and Environmental Design. In our project, we are going to use LEED PD plus C. building design and construction, as an assessment method to our project, in which we are targeting gold rating certificate. Our target point is between 60 to 79 points out of 100. LEED will evaluate the project and its environmental impact by assessing the following: location, sustainable site, water efficiency, energy and atmosphere, material and resources, indoor environmental quality, innovation, regional priority.